Hello all, welcome to my talk on Flamingo, a user-centric system for fast and energy-efficient DNA training on smartphones. We are all living in a time where AI is moving closer to the edge for a variety of reasons, and protecting user privacy is challenging uh, when training on sensitive user-generated data in the cloud. Federated learning solves this problem by training the model on device, protecting the data while only sharing the trained model with the overall AI application. Legal requirements like the EU's GDPR have meant that the data cannot be sent to any data center around the world for training. Personalizing applications like next word prediction on a smartphone keyboard have to adapt their AI models to a specific user and device. All of these reasons has meant that there is a growing demand for on-device training. In this talk, I'll focus on smartphones as In this talk, I'll focus on smartphones as the edge devices of interest. Smartphone processors are made up of heterogeneous compute elements on the same chip, including a multi-core CPU, GPU, and memory. The multi-core CPU, in turn, is made up of heterogeneous cores of varying performance. The performance-oriented big cores consume more power to minimize latency, and the little cores draw minimal power at the cost of higher latencies. Some CPUs have a big prime core, which is a tuned-up big core with higher clock speeds and a larger cache. The cores are exploited for their capabilities, for their specific capabilities, with higher priority user-facing applications being scheduled on the big cores and low priority background applications scheduled on little cores. Therefore, unlike cloud CPUs, the performance of an application depends on the type of core it actually runs on. Also, FYI, the new breed of Apple Silicon and upcoming ARM chips for Windows also follow the same architecture. All right. So training on smartphones presents two challenges. The first one being that the backends used to train these models are not optimized for the CPU architecture. Here we're looking at a radar chart of stats when training ShuffleNet V2 on different combinations of CPU cores on a Pixel 3 device with one big core, four big cores, and one little core, four big cores, and one big core. While the performance gap between the big and little cores is obvious, using four big cores turns out to be slower than just using one. This is because of excessive cache thrashing behavior in the convolution kernels when multiple threads share the same cache. Therefore, simply scaling compute does not always scale performance. Training on a smartphone is compute intensive, and can degrade user experience when running in the background. For example, the phone might become less responsive to user inputs. We evaluate this degradation in experience by looking at the reduction in the PC mark score with and without the background training. PC mark simulates a suite of smartphone applications like video streaming, gaming, to benchmark a smartphone's performance. Clearly, the smartphone user will experience degradation when the training is running in the background, and especially with entry-level devices like Pixel 3, they experience a higher level of degradation. To address these issues and enable on-device training, we present Flamingo. Flamingo is a system comprised of four different components, three of them that are based on the device and one that exists outside the device or smartphone. We have implemented Flamingo in Android within the Termex terminal emulator app. The first one is the device monitoring component that queries the status of the battery state of charge, and whether it is being charged. It also informs whether the device is idle or being used. The training backend performs the actual on-device training. We have picked PyTorch as a training backend since it supports training on all layers in mobile, which means that a model training on a server can be easily ported for training in a mobile by Flamingo. The final on-device component is the control logic of Flamingo. This is the central component that orchestrates the training, queries the device, and communicates with external coordinator or any other app that requires an on-device training service. The final component is located outside the device. If the smartphone is participating as a client in a federated learning application, Flamingo schedules training when requested by the FL aggregator and communicates the updated model back to the aggregator. The central coordinator is a database of performance profiles of smartphones, training a specific model, and helps reduce the cost of exploration for newer clients of the same smartphone model. I will expand on this exploration step in the next slide. Flamingo's workflow has three high-level steps. One, device monitoring evaluates the energy usage of background services to calculate the exact usage of the training application. It also ensures that the device meets certain criteria before starting the exploration step. The exploration step benchmarks different core configs for latency and energy usage to create a performance profile for the AI model and smartphone combination and prunes away configurations that are not Pareto optimal. The final step is the actual on-device training. Armed with the performance profile from the previous step, Flamingo starts training with the fastest configuration and dynamically adjusts its footprint to reduce contention with user applications. I will expand on the second and third steps in the next slides. All right, exploration. The exploration step benchmarks different core configs for latency and energy usage to create performance profiles. In the case of this specific performance profile, 4 big cores take more time than using just one big core. We therefore prune away the 4 big core config since it uses more cores than the second configuration and thus has a larger footprint without giving any benefit of lower latency. Using just one big core also allows Flamingo to run at minimum latency and train without interfering with other applications. All right, on-device training. Flamingo starts training with the fastest config. Once the user launches an application, Flamingo infers this interference through increased latency and downgrades its footprint to use less cores or lower performance cores. Flamingo monitors device load by intermittently trying to upgrade its footprint. After the user closes the application, Flamingo can then upgrade its footprint without interference, ultimately going back to its maximum performance. Therefore, Flamingo maximizes performance by dynamically adjusting its footprint for interference. Moving on to results. We evaluate Flamingo in 2 settings, one on-device and one distributed setting. For the on-device setting, we evaluated Flamingo on 3 smartphones and a tablet, training 2 vision models and 1 speech recognition model. Flamingo achieves an average on-device speedup of 12x and improves the average energy efficiency by 8 times, training a single mini batch. Flamingo also minimizes and eliminates the interference with the PC Mark benchmark on the OnePlus 8 and the Samsung S10e devices. In the large-scale federated learning setting, we evaluated Flamingo by emulating thousands of clients, training the same AI models as mentioned before. Flamingo improves the time to accuracy by up to 23 times. On-device training performance improvements across thousands of client devices results in improved overall training times for a distributed federated learning application. Flamingo also helps maintain a larger available client pool. The energy efficiency gains in on-device training directly result in clients maintaining their energy budget, making it easier to find participants. It also results in better user experience since Flamingo prevents participants from draining their battery. The first and the second figure show the baseline actually reducing the number of available clients because their battery runs out and basically their energy budget runs out, and you don't want your federated learning application to drain your user's battery. All right. To conclude, as AI moves closer to the edge, smartphones need to be able to train AI models and train them without harming user experience. Flamingo solves that problem by tuning the execution of an AI model to the smartphone and dynamically adjusting its footprint at runtime. Thanks for listening.